Let's explore how to calculate the high leg voltage on a delta transformer. Someone asked how to calculate it, mentioning a possible formula involving the square root of 240 squared minus 120 squared. The high leg voltage on a delta transformer, sometimes called a wild leg or stinger leg, is determined by multiplying the center tap voltage, also known as the phase voltage, by 1.732, which is the square root of 3. This 1.732 factor arises because the high leg voltage represents the voltage between the high leg and the neutral point. This voltage is not directly one of the phase voltages but is related to them through a geometric relationship in the delta configuration. Consider a scenario where the center tap voltage is 120 volts. Multiplying 120 volts by 1.732 gives approximately 207.84 volts. That is your high leg voltage. The formula involving 240 squared minus 120 squared and then taking the square root, as previously mentioned, is not the correct way to calculate the high leg voltage on a delta transformer. This other calculation appears to be an attempt to apply the Pythagorean theorem, but it doesn't accurately reflect the voltage relationships in a delta transformer with a center tap phase. The essential point is that the high leg voltage is 1.732 times the voltage from either of the other two phases to the neutral when one phase is center tapped.